Hello students, in this video we are going to start the subject which is for 18 Math 1-1 Calculus and Linear Algebra. So in this chapter in this paper we are going to see which is under the calculus and as well as a linear algebra also. So you have total 5 model. So we are going to start today with model 5 which is linear algebra. So first we will go to see the introduction about linear algebra, and after we are going to see the definitions of some basic definitions which is required as per your syllabus. Okay, so as we have already learned in school, so what we have learned in introduction about the linear algebra, we know already, right? Matrix. So what is mean by matrix? So matrix is nothing but when you have a numbers or elements is arrangement of rows and columns with a bracket. We used to tell as a matrix, isn't it? So you can go over that the matrix, just an example. So I can write it 1 2 3 4. So this is your matrix. So generally what we will tell 1 2 3 4 as an element of this matrix. So we used to tell what is that 1 and 2 is a first row and 3 and 4 is a second row, isn't it? Similar, 1 and 3 will be a first column and 2 and 4 will be a second column. So usually the order of a matrix, what is that? The order of a matrix is nothing but number of rows and number of columns. So usually we will denote the number of rows in small m and number of column will be small n. So m cross n will be the order of the matrix. Okay, and suppose see here which you have here, what is that? In this example the order of a matrix is nothing but 2 cross 2. Okay, so similar we can able to use that places also. So suppose you can have a matrix, you can take it example of 2 cross 2, so which a matrix of capital A. Okay, the element, each element I can use in small a. The first position will be first row, first column, isn't it? So that's why we will use A11. What is that? The second row will be second element will be the first row, isn't it? Same row I have in second column. So it will be A12. And similar, you can come to here A21. That is nothing but A second row, first column. Similar, you have A22. So it is nothing but second row, second column, right? So this is a simple 2 cross 2 matrix which you have it with the positions also has been mentioned it. So it's all the basic things about the matrix you have learned it, right? So now type of matrix. So what and all type of matrix we learned in the matrix? So you can tell that order is an m cross n. Suppose m is equal to n, what we will tell? This is that, for example, the previous one we have seen. So 2 rows and 2 columns. That means rows and column is equal. We used to tell it is for square matrix. Okay. So what is that? It is a square matrix. So it is like 2 cross 2, 3 cross 3, 4 cross 4, like that we can tell the rows and columns is equal. We used to tell it is for what is that? Square matrix. Similar, we have seen it diagonal matrix. Only the diagonal element will be there and only the column will be there. We can tell as a column matrix, and as well as we can tell as a row matrix. And we have learned about symmetric and skew symmetric. So symmetric is nothing but if you have Aij, right, in the matrix of A, you can interchange row to column, column to row, it remains same. That we can tell as an symmetric matrix. And similar, along with the sign is changing, we can able to tell as a skew symmetric matrix, isn't it? So we have learned so many type of matrix, right? Even for identity matrix. So what is that identity matrix? Identity matrix, if it is 3 cross 3, for example, it's supposed to be like this 1 0 0 0 1 0 0 0 1. We used to tell it as an identity matrix, right? So 0 matrix is null matrix is nothing but all the element will be a 0. Okay. So next one, matrix operations. So what and all the matrix operations we know? So the matrix operations, you can tell the additions, adding the 2 matrix, and you can go with the multiplications of 2 matrix, A cross B, B cross A cross B cross C. So all the operations we used to tell It is for matrix operations. And also we have learned what is that inverse of matrix. So you have already learned inverse of a matrix. What is it inverse of a matrix? If you have a matrix, so finding a inverse, what is that? 1 by determinant of A into adjoint of A. So what is that? Adjoint of A, we can able to find the cofactor of A, transpose will give adjoint of A, and the determinant of A is nothing but finding the determinant of a given matrix. If it is a 3 cross 3, what you will find the determinant of A matrix? You can take it as a determinant of particular A matrix, explained from the first row, and you can find a solution. That means find a value of your determinant A. So that using that we can find your inverse of a matrix. So this is all the basic things which we have seen the recalling part. Okay. So now we can into your main topic as per your syllabus, elementary transformation. So what is that elementary transformation? So we know transformations generally it's transforming one to other, right? So the general meaning of transformations. So now here the elementary transformation is the element, right? So some changes is happening in the element. So element is nothing but in the matrix every terms we used to tell as an element, right? So here we are going to do the elementary row transformation of a matrix. So row alone we are going to transform without affecting your main matrix, right? So in that you can use only the 3 tools which is given, like what is that? Interchange of any 2 rows. That means you have a matrix, so you can able to interchange the first row to second row to first row. Okay, so in that we'll be using like the symbol R1 is implied and implied by. That means it's going to change it in R2. So it's nothing but R1 is going to change R2 and R2 is going to change R1. Okay. So that is what will be mentioned here, interchange of any 2 rows. It's not only with R1 and R2. You can change, depends on your question. As per your requirement, you can able to interchange it by using a elementary transformation. The next one, multiplication of any row by a non-zero constant. So if you want to do the simplifications, for example, any row R2, I'm going to change it, which implies this is a new R2. How we are going to change it? I can use any non-zero row. I can use the negative or positive, but it should not be a 0. Okay. So 2 into R2 means what will happen? Entire R2 we are going to multiple with 2. That is what it is mentioned as multiplication of any row by a non-zero constant. The next one, additions to any row a constant multiple of any other row. So if you are multiple, if you want to make a changes in any one particular row, for example, I am going to change it in R3. So how I need to change it? I am going to use my old R3. Then I need to add with 2 into of R1. Okay, that means that you're doing a 2 operations. One is multiplying 2 within R1 and after that you're going to add with R3. Okay, which will give new R3. So this is the expansion. So like that you can use it any of the numbers based on your requirement. Okay, so this we can able to tell the additions to any row a constant multiple of the other row. Okay, so this is the example of the elementary transformations. So this is a major 3 elementary transformations. Only these 3 should be using it in the future problems. Okay, so elementary row transformation of a matrix is interchanging any 2 rows and multiplication of any row by a non-zero row constant and additions to any row a constant multiple of any other row. Okay, so the next one, equivalent matrix. So now you can do all the element changes. So what will happen? We can't tell it is directly equal, isn't it? So first row you are interchange the second row but remains same whatever is there in the given matrix. But we can't tell it is exactly A equal to which you have done it, right? So that time we will use it this equivalent matrix. So we'll see the definition. 2 matrix capital A and capital B of the same order said to be equivalent if one matrix can be obtained from the other by a finite number of successive elementary row or column transformations. So this is a general definition. So as per our syllabus, we have only row elementary transformation. So we are not going to change any transformation in column. But one thing, the additional information, whatever the elementary transformation we learned so far, the three type, it can be used in your column also. Okay. So the equivalent matrix is nothing but if you are telling the two matrices is equal, one matrix can be obtained from the other. That means from the A matrix, you are doing some simplification, you are getting a B matrix, but both are equivalent matrix. It's not an equal matrix, but it is an equivalent matrix. Okay. So we will use the notations like this: A equivalent of B. It's clear. So the next one, this is here. The major problem will start in this method, which is using the previous two definitions. What is that? Echelon form of a matrix. So what is mean by echelon form? A non-zero matrix capital A is said to be in the row echelon form if the following conditions prevail, right? So when you can able to tell it as an echelon form, okay? All the zero rows are below non-zero rows, and the first non-zero entry in any non-zero row is 1. So only these two conditions. So the condition is, if after doing all row elementary transformations from the given matrix, you are supposed to get, when you are getting in simplification in zero matrix, if all the entire row, all the element of that entire row is 0, it should be only from the last. That is what mentioned there. All the 0 rows are below the non-zero rows. So what is that? 0 rows means all the element must be 0. Non-zero rows means nothing but at least one should be there, 0, 1, 0, like that. If you have it, one element at least entry is there, at least minimum 1, and all the entry is the number, it is okay, right? We used to tell it is a non-zero rows. Okay, so that is should be only below the non-zero rows. First condition. Second condition is the non-zero, first non-zero entry. So other than the 0 row, all the non-zero entry, the first entry should be 1. That we will tell it as an echelon form. Okay, so these two is a major like point when you can convert an echelon form. So we will see with the example to understand. For example, you see what is order of this matrix. This matrix is 3 rows and 4 columns. So this is converted to the echelon form. So usually the echelon form you are supposed to convert. What is that? The first row, second row, first element, and third row, first and second element, you are supposed to convert 0. Okay. So this is a major rule when you can convert in echelon form, right? So this is a basic step to convert in echelon form. And meanwhile, you are supposed to check the 2 point. What is that? 0 row should be below the non-zero row. So here all it is a non-zero row. At the same time, see to the condition, first row, second row, first element, and third row, first and second element. Suppose you have a fourth row, one more fourth row, first, second, third should be up to convert to 0. Okay. So now how to make it 0, we'll see the upcoming videos. Okay. So now you can see that second condition, non-zero row, the first entry must be 1. So here is 1, here is 1, here is 1. So this is, we can call it as an echelon form. Okay. So now you can go for your next example. What is that? We have 1, 2, 3, 2. So see here, all non-zero rows, 1 is that is in the last. Okay, 0 row, right? Non-zero row, I have a 2. So it is that entry is there 1, 1 first. Clear? And second row, first element 0, we have done it, right? Similar here, third example. Okay, so this 3 is a best example. It is for the echelon form, when we will tell as an echelon form. So next definition, rank of a matrix. So just a additional step from the echelon form. Once you found an echelon form, easily we can able to get the rank of a matrix. What is that? The rank of a matrix capital A in its echelon form is equal to the number of non-zero rows. So once you reached in echelon form, okay, how many number of non-zero rows you have to count. So see, it is only counted with the rows, right? So number of non-zero rows, we can tell it as a rank of a matrix. So usually it is denoted by rank of A. So see, from here itself we can tell. So number of non-zero rows, what it is? All the 3 is non-zero row. So I can tell rank of this matrix is 3. You can see here, what is the rank? The rank of a matrix here only 2 because 1 0 rows there. Here also 2. Clear? So that's all for the rank of a matrix. Okay. So before into the problem, we'll see some note. If R, you can tell it is a rank of a matrix of capital A, which is the order is M cross N. So if R is less than M. So R, number of rows of a matrix are linearly independent. So if when you are getting a rank of a matrix is less than or equal to here, what is that? The number of rows, you can tell it is for linearly independent. Okay. So that's all. Thank you.